we're given that the function w is a function of z, and the function of z is z conjugate, that's the bar z, plus 3z conjugate plus 4. You must find f, the function, f of 3 plus 4j. Okay, so remember, as usual, you must write down the question and then pause the video, write the question down, and then ensure that you make a genuine attempt at it. Alright? Now, remember, f of z is equal to z bar plus 3 z bar plus 4, where z bar is the conjugate. Alright? Now, this is no longer f of z, it's going to be f of 3 plus 4j. See that they use j here. Now you're going to replace z with 3 plus 4j. So this is 3 plus 4j. But I prefer saying j4. 3 plus j4. And the conjugate is 3 minus j4. Alright? Plus 3 times 3 plus j4. See that? Plus 4. Okay, good. Now, if you should multiply this out, 3 times 3, that's 9. Plus 3 by negative j4 is minus 3 by negative j4, that's 3 4 12 minus j12 plus 4 j4 times 3, that's plus j12 minus j4 by j4, means j squared 4 squared, right? Plus you open the bracket here, 3 3 is 9 plus 3 4 is 12, that's j12 plus 4. Okay, ensure you're following. Now here, this is going to be 9. Negative j12 plus j12 is 0. So the next thing we have is minus j squared, 4 squared. But j squared would be square root of negative 1 squared, which is negative 1. So it's minus negative 1. 4 squared is 16. Plus, okay, we can just add the 9 and 4 from now. 9 and 4 is what? 13. 13 plus j12. Now, this is going to be 9 minus negative 16 is 9 plus 16. 9 plus 16 is going to be 25. 25 plus 13, 5 and 3, 8. 2 and 1, 3. So you get 38. So when you add the numbers, you get 38 plus j12. Alright? Now, here, again, this is 3 plus j12. This is a conjugate. Oh, guess what? It should be 3 times the conjugate. Okay. Let me correct that. That was a mistake there. 3 times the conjugate of z, not 3 times z. So this is 3 3 is 9 minus 3 4 is 12. So this is going to be 9 plus we have negative 16 plus 9. 9 and 4 13, but this is a negative j12, right? So this is a minus j12. Alright, so that was a mistake there. Okay. So there you have that. F of 3 plus j12. Part 2. What's the real and imaginary part in f of 3 plus j4? Well, part 2, the real part, right, of z would be 38, right? And the imaginary part of z would be negative 12. Not j 12, just negative 12, alright? That's the imaginary part. Because it's j times the imaginary part. Let's see what else is here. Find the natural logarithm of f of 3 plus j plus 4j, or j4 as we call it. So we're going to find ln of 3 plus j12. Okay, now to find the natural logarithm, remember we're going to write it in exponential form first, right? So the function 3 plus j12, we're going to call it r e to the j theta, and theta will be using radians, alright? Now here, the real part, what is it? I mean r, not the real part, the magnitude is really r. This can be written as the magnitude of z e to the j theta. We usually call this r because it represents the radius of the circle, right, that the function number exists, the imaginary number exists in. So what is z? It's going to be the square root of 3 squared plus 12 squared. Now this is, remember, it's 3 plus, what did you say again? Oh, plus j4. My. It's 3 plus j4, not j12. 3 plus j4 it should be. So it's 3 squared plus 4 squared, which is 9 plus 16. The square root of 25, which is 5. So the magnitude of the complex number is 5. Now, remember, 3 plus j4, if you have an x and y axis here, and you want to plot the complex number, you go out 3. Oh no. You go up to the right 3, and plus j4 means you go up 4 places. So what you would have is this point would be above 3 and beside 4. Now what we want is this angle, call it theta. Now the tan of theta is the opposite. The height is 4. Remember, this would be 4. If you plot this as a triangle, this is 4 over the adjacent, opposite over adjacent, this would be 3. Alright? So therefore theta is equal to the tan inverse of 4/3, which is what? Let's see if we can find that. The tan inverse of 4/3 is we want to use one of these calculators. Let's use this. No, we want it in radians. You could find it in degree then convert to radians, but let's look at it in radians. I have my calculator in radians. 4 divided by 3 is that. Alright. Oh, this calculator. The tan inverse. Where's the tan inverse thing again? How do I get the tan inverse again? With this calculator, is it shift? Arctan. Oh, so it's going to be, let's clear 4/3 equal, and then shift and arctan, same as tan inverse. I will get 0.927 radians. Right? Theta is 0.927 radians. So 0.927 radians. Alright? So we now have the complex number in exponential form. Z is equal to 5 e to the j 0.927. Alright. Now, the natural logarithm of z is equal to the natural logarithm of 5e to the j 0.927. Now, what is this equal to? Remember, when you find one number times the other number, then you log that, the answer is the same as log one number plus the log of the other number. Alright? So this can be written as the natural log of 5 plus what 5 is multiplied by, which is e to the j 0.927. So it's plus natural log of e to the j 0.927. Alright? Now, what we have here is ln 5 plus. Now remember, one rule of log is that the log of a number to a power is same as you bring down the number to the left and multiply. So you say power the number times the log of the number, the power times the log of the number. So if you bring down this power of e here, the power of e is j 0.927. So the power time the natural log of a number, right? But what is ln e? It's 1. So ln z is equal to ln 5. We could work on ln 5 and see what it is. Clear 5 ln 1.609. So this is 1.609 plus j 0.927. Alright? So that is the natural logarithm of this complex number. Alright, I will see you in the next video then.